Hello everybody. This is your Algebra 1 Test 5 review. The test is going to be on Thursday, April 17th, and the only exception for that is period 1, who will not be seeing on Thursday. They will take the exam on Friday, April 18th. So, let's get into it. Number 1 is asking for the roots of the equation. Well, we know that the roots hit the x-axis, but based on the fact that I see my answers have radicals in them, I'm probably not going to be able to do it that way. So I have to do this the old-fashioned Mr. X squared way, and being how the answers are telling me it's not going to factor, I know if it doesn't factor, because there's something that multiplies to 16 and subtracts to 4, I have to do my quadratic formula. This is on your reference sheet. We also have the song to help us remember this. When doing this, list your A, your B, and your C values. A is 1, B is 4, C is negative 16. So if B is 4, negative B is negative 4, plus or minus radical, B is 4, A is 1, C is negative 16, all over 2 times 1. Next, I want you to do what's inside the parentheses. You can use a calculator if you want to. I suggest that you do. You get 80. The next step a lot of students forget to do. You have to reduce the radical. So you break your radical into your perfect squares and your non-perfect squares. It's helpful to write them out. You end up with 4 radical 5. So when I rewrite now, I replace the 80 with 4 radical 5. Now, finally, I want to reduce this if possible. If anything goes into all 3 terms, we can reduce them. Yes, 2 goes into all 3 terms. So I'm left with negative 2 plus or minus 2 radical 5. Practice quadratic formula. Number 2 is simple if you know how to do the problem. Which statistic would indicate that a linear function would be a good fit to model a data set? Well, if it's close to 1 or negative 1, that makes it best. Whatever's closest to 1 or negative 1 without going over it. Which of these is closest to 1 or negative 1? Choice 2 is. Number 3 is very similar. If I draw in my line of best fit, it says which could be the correlation coefficient for the given scatter plot. Well, because it's got a positive slope, it must be positive, so it can't be choices 2 or 3. 0.99 would indicate that the points are very, 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 very close to that line of best fit. That's not the case here. 0.82 is good, but not great. It still forms a line. They're not exactly on the line. Choice 4 would be your answer. They wouldn't give you one where they had a 0.82 and a 0.83. You wouldn't be able to determine that from this. But you have to understand the ballpark of where it would be. Word problems. Again, 1 sentence at a time. Draw a line at your period. Only look at the first sentence. A satellite television company charges a one-time installation fee and a monthly service charge. Nothing really mathematical there, but this one-time installation fee and monthly service charge, or charge per month, is making me think this is going to be a per x plus the one-time fee problem. I'm going to read on to the next sentence. The total cost is modeled by the function y equals 40 plus 98. Yes, I can tell it's a linear function now. It definitely is. Per is in front of the x. So the 90 is the per, and the 40 is the one-time fee. It says the total cost is y, and the x is your per. So in this case, that's your per month. So choice 1 says y is the total cost. Yes. X is the number of months of service. Yes, it's per month. 90 is the installation fee. 90 is not the one-time fee. 40 is the one-time fee. So that's not the answer. Y is the total cost. Yes. X is the number of months. Yes. 40 is the installation fee. Yes. 40 is your one-time fee. And 90 is your service charge per month. Yes. 90 is your per. That's your answer. Isaiah collects data from 2 different companies, each with 4 employees. The results of the study based on each worker's age and salary are listed in the tables below. Which statement is true about these data? Well, we have to go through each choice and take a look. The median salaries in both companies are greater than $37,000. Well, I need to know the median salaries for each. The mean salary in choice 2 in company 1 is greater than the mean salary in company 2. I need to know what the mean salaries are. The salary range, I need to know what the salary range is. And choice 4, the mean age. So, I need to do some calculations. This is 4 different data sets. There's no L1 and L2 to use here. We use L2 when there's a frequency list. There is no frequency list. So I'm going to find the mean, the median, and the range for company 1 and for company 2. I'm going to forget about choice 4 right now. Alright, let's just do 1, 2, and 3 first and see if we get an answer. Now, to do this, we use our calculator. I'm going to do one of them for you. I'm not going to do all of them. But in case you forgot what to do, you go stat, enter, clear out what's inside, up, clear, enter, up, clear, enter. So I'm going to do my company 1 salary in dollars. So I got 30,000. I've got 32,000. I got 35,000. I've got 38. Oops. 35,000, and I got 38,000. Stat, calc, 1 variable statistics. Yours is a little bit different than mine. Turn it down to calculate. I know my x bar is my mean. My mean is 33,750. My median, I scroll down. My median is 33,500. My median's right here. My range, well, my range is my max minus my min. Here's my max. Here's my min. 38,000 minus 30,000 is 8,000. Now I would repeat the process for company 2. I did it in advance. You go through the whole process. When you do that, you should have gotten 41,625 for the mean. The median was 36,250, and the range was 36,000. So the median salaries of both companies are greater than 37,000. No, in fact, neither of them are. The mean salary in company 1 is greater than the mean salary in company 2. Nope. Salary 2 is higher. The salary range in company 2 is greater than the salary range in company 1. It sure is. That's my answer. In order to check choice 4, well, I would have to find the mean for this data set and the mean for this data set and compare them. I am not going to do that now, but I already have my answer. Number 6, the zeros. Well, if you know your song, you know that the roots and the zeros are the same thing, and the zeros hit the x-axis. There's 2 ways to do this, just like number 1. This is the same type of problem as number 1. Number 1 we did algebraically, but this one I'm going to do graphically. Because looking at my answers, they're whole numbers, they're integers. So, I'm going to type in the problem into y equals x plus 2 squared minus 25. I'm going to look at my graph. I don't have a good graph right now because I was messing around with my scatter plots. So I'm going to go to zoom 6 to find a nice one. I'm going to do it one more time. Zoom 6 is standard. That'll give you a nice picture. The zeros hit the x-axis. It hits it here. That's positive 3. And it hits it here. That's negative 7. Negative 7, positive 3. Your answer is choice 4. Which domain would be the most appropriate set to use for a function that predicts the number of household online devices in terms of the number of people in the household? Well, domain is your input. Domain is your x value, and your input is the number of people in a household. So, which set of numbers would define the number of people in a household? Well, integers include negative numbers. Negative 5, negative 4, negative 3. Can you have negative people in your house? No, you can't. Whole numbers. That would be 0, 1, 2, 3, 4. Can you have 0 people in your home? Yes. 1, yes. 2, yes. 3, yes. 4, yes. 5, yes. That's the answer. And for these real-life domain problems, the answer is always going to be whole numbers, or they might phrase it as non-negative integers. And they ask the same question over and over again. I'm going to ask you the same question on the test. I'm telling you right now, the answer is going to be whole numbers or non-negative integers. On the Regents, they're going to ask you this question, and the answer is going to be whole numbers or non-negative integers. Now, the reason it's not irrational numbers, well, 0.4123659201, etc. Can you have that many people in your home? No. And rational numbers can be decimals. Can you have 0.7 people in your home? I don't know what kind of people you're inviting in that are 0.7 of a person. And no, babies don't count as fractions. Whole numbers is always your answer for these real-life domain problems. Box plot. Well, use your calculator. We just went through the process before to find the mean, the median, all that, so I'm not going to pull the calculator up again. But you need your min, your Q1, your median, your Q3, and your max. The calculator tells me that my min is 7, my Q1 is 17.5, my median is 38, my Q3 is 42.5, and my max is 60. Again, I got these from the calculator. Now, my grid has to start less than or at the min. If the min is 7, I did some finagling. I started at 6, and I went by 6s. 12, 18, 24, 30, 36, 42, 48, 54, 60, 66. I put dashes at each value. It's got to be approximate. 7's got to be a little bit bigger than 6. 17.5 is going to be a little bit smaller than 18. 38's got to be bigger than 36. 42.5 is going to be a little bit bigger than 42. 60 has got to be, well, at 60. Your box connects your quartiles. Your whisker connects your box to your max and your min. And that, my friends, is a box plot. Or a box and whisker plot, as they used to call it. The table below shows the average diameter of the pupil in a person's eye as he or she grows older. That's fantastic. What is the average rate of change? Average rate of change, we have a song for this. Average rate of F of B minus F of A over B minus A. I bet you thought I was going to start singing. Nope, you got to go over to the songs playlist to hear that one. This one's my fave. Now, it's asking for the average rate of change in millimeters per year of a person's pupil diameter from age 30 to 70. So here's my A, and here's my B. Is it giving me F of A and F of B in this example? Yes. That's what this value, that's what the 4.3 and the 2.7 are. So F of B is 2.7 minus F of A is 4.3. B minus A is 70 minus 30. From here, you can just put this into the calculator. I would do it as alpha y equals enter, and you should have gotten negative 0.04. So negative 0.04 millimeters per year. So every year, your pupil is decreasing by 0.04 millimeters. Oh well. A small country in Europe has been experiencing population growth that can be modeled by the equation y equals 120,000, 1.042 to the power of x. Well, you should recognize this as an exponential equation because it's an exponent, which means it is AP1RT. Is it plus or minus? Well, is this number bigger than 1 or smaller than 1? It's bigger than 1, so something's being added. Now, here's what you need to know. P, what's in front of the parentheses, is your principal, which is your initial value. It's super, super, super important. You understand that the number in front of the parentheses is your initial value or your starting value. Now, this value inside the parentheses is a little bit more complicated. It's 1 plus or 1 minus the rate. So what's being added to 1? Well, it's 1 plus 0.042, which makes the rate 0.042. At the percent, I would have to move the decimal over 2 places or multiply by 100 to get 4.2%. That's the percent of change. The question is asking, what is the percent of change in the population of the country each year? This is the answer to the question. It could have just as easily have said what was the initial amount of the population. It could have asked what each thing represents. So it's very, very, very important that you know what each component represents. The table below shows the concentration of ozone in Earth's atmosphere at different altitudes. Fantastic. Write the exponential regression equation. Simple. My calculator does that for me. So I'm going to pull up my calculator. I'm going to turn it on, which is very important. If you don't turn your calculator on, you're going to probably have some problems. And I'm going to hit stat, edit. Clear this out from earlier. Type in my 0, 5, 10, 15, 20. Oops, looks like I missed 1 there. And my 0.7, my 0.6, my 1.1, my 3.0, and my 4.9. The calculator round, which is why the 3.0 is a 3 and the 0.7, 0.6 lost a 0. It wants an exponential regression. Stat, calc. Tab down to exponential regression, which is option 0. Enter. Your screen looks different than mine. Just tab down to calculate. Now it tells me y equals a star b caret x. We know in high school what that means. If you don't know what that means, I'm going to tell you. Well, we write multiplication as parentheses. And we write the exponent up top. Now it wants me to round to the nearest 1,000, so that's 3 decimal places. So a to the nearest 1,000 is 0.488. The next digit is 1, so the 8 stays, 0.488. Rounding is so important in this. B, 1.116. The next digit is not 5 or higher, so it stays 6, 1.116. To the power of x. When it writes for an equation, you must have a y and an x. That's my equation. It's not asking me a follow-up question. If it did ask me a follow-up question, then I would substitute my value for x after I have my initial one. A nutritionist collected information about different brands of beef hot dogs. Good for her. She made a table showing the number of calories and the amount of sodium in each hot dog. Ew. Write the correlation coefficient for the line of best fit. Well, to get the correlation coefficient, just like the linear regression equation, I need to go to my calculator and type in my data. I will do it for you. You do it on your own as well. 186, 181, 176, 149, 184, 190, 158, 139, L2, 495, 477, 425. You know, I'm going to break my voice for a few seconds here. Okay, I'm back. Now that everything's typed in, I go to stat. I go to calc. Now, it says line of best fit. If it's a line of best fit, then it must be a linear regression, option 4. Now it's asking for the correlation coefficient. You need to know that the correlation coefficient is R. R is the correlation coefficient. R to the nearest hundredth is 0.94. If you don't see your R and your R squared, second 0, tab, scroll all the way down. This does not work well on the smartboard, so bear with me here, but I will show you anyway. Don't mess up. Come on, almost there. Getting close. Almost there. There we go. Diagnostics on, enter, enter. Okay? Now, if you do it again, you should get your R. Explain what the correlation coefficient suggests in the context of this problem. Well, 0.94, that's a pretty good correlation. It's very close to 1. So, that means there is a strong positive correlation between the calories and the milligrams of sodium in a beef hot dog. Even though, for those of you who know your nutrition, sodium is not calorie yielding, there still is a correlation. Boom. The vertex of the parabola, represented by f of x equals x squared minus 4x plus 3, has coordinates 2, -1. So this is the vertex. I could graph the whole thing. It's not asking me to, so I'm going to hold off on that. Find the coordinates of the vertex of the parabola defined by this. You need to know what this means. When you're adding or subtracting to f of x, it is a translation. It's moving up, down, left, or right. I'm subtracting from the x, so it's moving horizontally. And because it's minus, it's the opposite direction as you would think in parentheses. So this is going right to. This is saying the parabola is moving right to, which means the vertex is moving right to, which means this is the new vertex. The coordinates of this point are 1, 2, 3, 4, -1. You could have graphed the whole thing, didn't have to. Understand and know how your transformations of functions work. You have a whole page in your team your standings on that. We're up to the last question. Word problems. So again, I'm going to break it down one sentence at a time. Next weekend, Marty wants to attend either Carnival A or Carnival B. Anything mathematical? No. I don't really care what Marty wants to do, but I'm going to read out anyway. Next sentence that's here. Carnival A charges $6 for admission and an additional $1.50 per ride. Ooh, I see a lot in there, and I see some key words. When I see my per ride, I know that this is going to be per X plus the one-time fee. So let's do it for Carnival A first. A of X equals, it's $150 per ride. So it's $150 X. The one-time fee is $6 for admission. So here, A of X represents Carnival A, or the cost of Carnival A. And I'm going to use B of X for the cost of Carnival B. And X is the number of rides. It's per ride. So that's what that is. B of X. I'm going to read my next sentence now. That ends right here. It's $2 per ride, so it's 2X. The one-time fee is a $2.50 admission, plus $2.50. A, in function notation, write A of X represents the total cost of attending Carnival A and going on X rides. In function notation, write B of X to represent the total cost of attending Carnival B and going on X rides. Just did that. That's this right here. B, determine the number of rides Marty can go on such that the total cost of attending each carnival is the same. Same means equals. So I need to take Carnival A, 150X plus 6, and set an equal to Carnival B. Now I solve my equation. Minus 150X minus 150X, 6 equals 0.5X plus 2.5 minus 2.5. If you're afraid of the decimals, you can use a calculator to help you. Divide by 0.5. And let's go a little bit more, why not? You get X to be 7. So 7 rides until the costs are the same. Great! We got another question, don't we? That was B. We got a C. Done with that. Marty wants to go on 5 rides, determine which carnival would have the lower total cost. Right? This is why we have functions. A of 5 will tell me how much it will cost for Carnival A, and B of 5 will tell me how much it's going to cost for Carnival B. So that's 150 times 5 plus 6, and this is 2 times 5 plus 250. Put each one into the calculator. When I did that, I got 1350 for A, and I got 1250 for B. So if you don't like to spend money necessarily, you should have picked Carnival. Carnival B is less expensive. Than Carnival A for 5 rides. If it was a different amount of rides, it might not be cheaper. That's why it's good to have a plan. That is it, ladies and gentlemen. It's been a pleasure. I hope you enjoyed the 29 minutes and 25, 6, 7, 8 seconds that I spent with you, and I hope you spend plenty more utilizing this, not just watching it, but utilizing it to do the problems. Do the review sheet. If you get stuck, use this to help you. Then redo the problem. Find more problems in your old worksheets. You have plenty of materials to use. Use your key understandings to help you as well. And spend a good amount of time between now and the exam so you can have a strong finish to the third quarter. Peace out.